We are repeating the same experiment. We did recently we did the experiment using stainless steel. Now we are doing the experiment with 3D printed material. This we have printed in our own lab. In this 3D printer. This is a cantilever beam with tip mass. Okay. This blue one, it is fabricated using the TPO material, thermoplastic polyurethane. Okay. This is ductile material. Okay. Ductile, sorry, it is elastic material.
Yes.
So its stiffness is less, and we can deform it. Okay. It is ductile, and this orange side, it is PLA, polylactic acid material. It is brittle material. Okay. Its stiffness, the Young modulus is between 20 to 40 megapascal. Stiffness is less. So here we have tried to design both of them whose their natural frequency is approximately same. It's between 10 to 20 hertz. So here we will show that the ductile material, it won't break at its natural frequency, but it may break. May break, not that it will, but it may break. Because brittle, they don't have any elasticity. It will just break. So here we'll do this experiment, and after that we'll show one demo of 3D printing in our system. I am increasing the frequency. See this is the approximate resonance condition. Both. It is also vibrating. This also. You can see.
It has a higher temperature.
No, amplitude is because length is more. Na? Frequency is same for both. It is having high amplitude because of its more length.
Moment and its more.
It just passes the resonance condition. Okay.
Okay.
If it moves in the resonance condition, it will break. We don't want to break it.
From the value you get to know the resonance frequency, or just the seeing you can tell
we use the spectrometer, no? Then we can see the resonance
just by
condition.
seeing we cannot say that.
Just by seeing we cannot say. We can approximately say that this is the resonance condition. Yeah. This. But we don't know, na? See, this is around. This is 27 hertz. 26 hertz will also show this 25. It is between 25 to see. This is 28 hertz. Okay, and this is 27 hertz. You can see the difference. 27 and 28. So the net shifted. So we will use the accelerometer to measure it. Now we'll connect the accelerometer here. We'll show how to measure the data in the system.